Thanks again for your flexibility today. Sorry about the sickness. I just didn't feel good about coming in and didn't want to expose everyone. So, main thing we're going to be working on today is the cousin to what we learned maybe about 4 weeks ago, something called Euclidean distance, right? If you remember that, was essentially like the buffer of the raster world, how you measure distance in a straight line. We're working tonight with its cousin, which is cost distance, which I think the best way to think about it might be, you know, if you actually had to move through space, like if the example I always give, if I'm trying to walk from, where I'm seated to maybe where Anastasia usually sits in front of me, from a Euclidean perspective, yes, if I just go straight over the desks, that's how far I actually am from him. But my true distance from her is actually a little bit farther, right? Because I would walk around the desk and then go in between the two rows because the cost I would accumulate in walking over the desk would be more. And we can measure that cost in a number of ways, right? That cost could be true distance, or it could be time, could also just be something intangible. Um, Embarrassment, right? Risk that I hurt something. Risk that I'm going to run into my ex is like a joking example we're going to do later in class. You could have also done this, and this is something you could have done for your zombie project. Obviously, you didn't know these skills then, but the cost could be the amount of people that you would eat along your way, right? Based on the density of things. So again, let's start by maybe showing the Euclidean distance and reminding ourselves of what that was, just until we get beyond that point. So I want you in the November 16th class folder, you'll see something that says Camp Com layer. Drag that in. It's going to tell you can't find the data. Remember, just click on the sign, navigate to wherever you're choosing to store this data. Give me 1 second to remember exactly where. And link it to the real raster. Right click and zoom to it. And there we go. So I've got a nice little raster that I've set up. If you click on the properties and go to it, you can see that it's actually a 1 foot by 1 foot raster, so it's pretty small. And it's meant to just convey the the different land uses that are in Philadelphia University, right? And the really tiny cell sizes and those land use values. If I'm to open my attribute table, tell me a value of 0 is just the land, right? The green land. A 1 is driveways, 2 is paths, 3 is buildings, 4 is streets, 5 is one crosswalk, 6 is a sidewalk, and so on and so forth, right? So all kinds of different values here that we can play around with. And that's essentially what we're going to do as we move forward here. So permit me 1 second. All right. So that's our area here. And if I were to drag in from vectors, if you go down here to vector and then maybe there's vector, start with origin. And then, change that so it's a little easier to see. Got it right down here. So if I were to use that and then, come up here perhaps and come down to spatial analyst. And remember, if you're working for the first time, again, you want to come to customize extensions. Oof, that's very annoying. Make sure that spatial analyst is turned on. So if I were to come to distance, and also apologies, make sure you want to come up here to geoprocessing and environments. Make sure your processing extent is the same as campus combined. And your raster analysis is also the same as campus combined. So if I come to distance and I go to Euclidean distance, and I drag in my origin point, right now I'm just going to say measure my distance, and I'm going to quickly make myself a folder for today. Right, it gives us essentially a familiar example, right? We're proceeding radially, right? I'm going to take this, I'm going to go here, go to symbology, display. Right, and we started here, and as we're moving outward radially, our distance is, increasing or decreasing. I can go to my pixel inspector and just kind of start here at the point. Make sure my pixel inspector is showing Euclidean distance. All right, you can see it's increasing in kind of that nice little linear fashion, cell by cell, as I move farther and farther away. There's no impedance. It's the same distance to get here as it is to get here. And that's Euclidean distance. And right, I've got this slide that I prepared for you. I'm going to quickly make a duplicate of it so that we're not necessarily seeing the comparison yet. But really, this is what's happening when you're running a tool like Euclidean distance, right? So let's say the cell size is 1 foot. Behind the scenes, you don't see it, but almost imagine there's like an invisible raster that I'm going to call a cost raster. I've also heard it called a friction raster. It lays on top of the surface, and it's almost like a toll. It's essentially a charge that says, you pay me this much to pass over myself. And that charge, as we're going to discuss throughout this class, can be many things, right? Risk, opportunity, time, zombie human consumption, whatever you want. When you're running Euclidean distance, the cost grid is always 1. There really is no cost to go over a cell, right? It's simply the distance to traverse it. And that's how you calculate distance. It's simply the cost of your cell times the size of the cell, or if you're going to go diagonally, if you remember when we did the Pythagorean theorem a couple weeks back, right, you do 1.41 if you're moving on a diagonal. So if I were to start here and I wanted to go to this cell, I'm only charged 1, right, to do that navigation, so it's only 1. I'm only charged 1 to do that navigation, so my distance from that would be 2, right, because distance is cumulative. So that's how things proceed in that linear fashion. Cost distance is going to be a little bit different. So in order to do cost distance, though, you need to set yourself up what's called a cost grid, right? So it's essentially a grid that let's say it charges a tax and a toll, right? A different value for each cell. And the way we're going to set up our first one, I want you to come to reclassify, and I want you to drag in campus combine. And we're going to pretend right now that like buildings we can't walk through, just for an example, so set them to no data. All of the crosswalks are going to be 1. The driveways will be 1. Let's pretend that we're trying to respect the landscaping, right? Maybe we don't want to walk on the land anymore, so let's make that no data. Or rather, we can keep the land. We can walk on the land here. Keep that as 1. The pathways are obviously 1, sidewalks are 1, and I don't want anyone walking in the street. So everything went to 1, except the streets and the buildings have been set to no data. We don't want our ability to go through the buildings or to go on the streets. So I'll set this as first cost. Right, raster is the art of classifying what's not quite there. Right, we've just got a nice easy thing here where I can see there's a value of 1 representing all of those things, right? And I can remind myself that it is in fact a value of 1. So if I now come over here to spatial analyst and then go down to distance and I find cost distance, what's kind of neat about this is I can drag in my origin, place I'm coming from, and the big difference, we'll get into some more in source characteristics for a second, but the big difference it's asking me here is to input a cost raster. So again, it's not that that doesn't happen when you calculate Euclidean distance, but in order to get this outcome that we got, it's almost like that is the cost grid I drug in. It's just every cell happens to be 1. But I'm doing it differently here. Now I'm saying, well, this is what it's like. Like, consider all the area in blue That's a 1. You can just traverse this like it's no problem, but anywhere in white you can't go on, right? I've made it no data here. I've essentially removed that cost. So how would that actually impact what my distance would look like? And so I'll call this cost distance. Right, we've got our tiny cell sizes here, and it's a nice little algorithm, so give it a quick second. And open it up, and we can see something that is like definitely radically different here, if we compare these two. So let's, open the first one, the Euclidean distance. And it's, moving from about 0 to 4,796, and you can see it moves in that kind of radial fashion. All right, very good. Cost distance, however, is completely different. Right? It seems to be the same, although even there doesn't have the same kind of nice radial depth, right? Because I can't just walk through these buildings. I've got to walk around them to get here. Most notably, you can start to see interesting differences when you get to places like the other side of this street. Well, think about it. From a cost distance perspective, since you're not allowed to walk on the streets, in order to get here, you had to go all the way up, cross that crosswalk, cross this crosswalk, and then start walking back on that sidewalk here. Same thing with this. It's the reason that, for example, if I am to go and zoom in, for example, right on this area here, and I'll take out my pixel inspector, and I'll just click on an area right here. So in the upper left corner, to get to that area, is the quickest distance away Euclidean. As the bird flies, it's 2,123 feet. But if I have to abide the rules that I said in cost distance, no buildings, no streets, it's actually 2,300 feet, right? There's an extra 200 feet to get there I have to take, and that makes sense, right? When I'm walking from here, given the rules that I set myself, I have to avoid the buildings, then I can kind of make a nice little beeline. But even then, I have to then get on this exact crosswalk, right? I can't cross anything else. I've got to hug the edge. I've got to get on this crosswalk. I can't just cross the street diagonally again, right? So it starts to add a little bit of distance when you start to modify where you can and where you cannot pass. So this is the first video. What I'm going to want you to do for this one is just complete that exact same thing. Show me the difference between a Euclidean distance and a cost distance from this point. If the cost grid you had set was just turning all values to 1, except the buildings and the streets would be no data.